Hello everybody, welcome to this video on graphing cosine and sine functions. This video will include shifts, scaling, and reflections of all these in the examples. So stay tuned for that, but let's get started. So we have cosine of x over here, and we have sine x over here. So these are two trig functions, and they are also cyclic functions. Cyclic functions means there's a cycle, and with a cyclic function comes maybe a new vocabulary word, periods and amplitude. So a period is the distance it takes to make a full cycle. So this, if we just highlight a cycle, this is half a cycle and a full cycle. So this right here would be your period, and this right here is called your amplitude. I'm just going to write amp right there. Okay, and why is this cosine x and sine x cyclic? Well, if we come up to the top right hand corner, we have a unit circle. These functions, when you graph them, you're essentially just graphing this unit circle, right, for whatever that function is. I keep talking about graphing. Let's just finally do it here. So we got cosine x, we're going to have an x-intercept at negative pi over 2, and another x-intercept at 3 pi over 2, and one more in between at pi over 2. Okay, so this is going to come up, hit a y-intercept at 1, and come right back up. And since it's cyclic, it's just going to keep going. Right, unless you define some endpoints, it's just going to keep going. Okay, so what is the period over here? Remember, a period is the distance of a full cycle. So that's half a cycle, and this is a full cycle. So we can come down here, label this period. This period is from negative pi over 2 to 3 pi over 2, which is just 2 pi. Okay, what about our amplitude over here? We are just going to have an amplitude of 1. Okay. So let's write that down here. We're going to have a period of 2 pi, and I'm just going to write amp of 1. Okay, so let's come over to our sine x, and this is a really easy trig function to graph. You just start at negative pi. Let me try again on that. One more time's a good, will be good. And we'll have positive pi over here. This will come down to 1, come up to 1, and end right there. And like cosine x, this is just going to keep repeating. But let's fill in this cycle. Now it is a full cycle. So what is our period? Our period is negative pi to pi, which is just 2 pi. And our amplitude, your amplitude is just the max height, the height of your crest. Okay, so imagine a big wave in the ocean, right? If this is your big wave, this is your amplitude, right? It's just the height of that wave at the crest, and this point would be the crest. So hopefully that makes a bit of sense as to what amplitude actually is. I'll just write amp over here. Okay, so our amp, in this case, you have a max height at 1, a min at negative 1, so our amplitude is going to be 1. So it's basically the same thing as cosine of x, and with proper shifts and reflections, we can actually make it look the exact same just by doing shifts and translations. Let's get into our first example. Okay, and for this first example here, we will have the function of y equals sine 2x. All right, with that 2 in there, I know this is going to be a horizontal compression by 2 times. So sine, our normal sine function, is just going to be being compressed. But let me just draw our normal sine function. And I'm just going to, right, that's green. This will be coming down, so come up. Something like that. And remember, this is negative pi. This is positive pi. Okay, so let's graph this y equals sine 2x, and we'll put this in yellow. Okay, so if I'm compressing it by 2 times, my next x-intercept is just going to be this divided by 2. Okay, so this will be negative pi over 2. And the same thing on the other side, positive pi. We will just have positive pi over 2. And it's going to say, excuse me, follow the same behavior as the parent function of sine x. Okay. All right, so let's try to find our period here. Remember, the period is the distance it takes for a full cycle. So I'm just going to highlight this cycle so I know exactly what I'm looking at here. All right, and we come down here. Okay, what's the difference between negative pi over 2 to pi over 2? That distance is pi, so I know my period is pi. And what about my amplitude? Well, nothing changed in my vertical scaling, so my amplitude is still just going to be 1. Okay, now if you're confused about how I was able to know that this was a horizontal compression when I just looked at that, how I knew that 2 was going to be compressing it, if we come over here and just write out just pretty basic function here, but it allows you to understand how shifts and scaling works. So let me just write this out real quick. Okay, so in this case, our f of x was just sine 2x. All right, so our b in this case was 2. So that's where that 2 is coming from. That's just that. But let's kind of define what each of these numbers do. This is a vertical shift. And I expect for many of you, this will likely be a review. So if you want to, just go on and skip ahead to the next example. C is a horizontal shift. B will be horizontal scaling. And there will be, if this is negative, if B is, I'm just going to put negative, there will be reflection about x equals negative c. All right, and this is going to be vertical scaling. And if this is negative, if negative, reflection at y equals d. Okay. So if you're still confused, I'll have a video in the top right-hand corner highlighting a video about shifts and scales. Go ahead and check that out and come right back to this video, and I think things will make a lot more sense to you. All right, let's move on to the next example. Okay, and let's jump into another example here. This example here, we're going to have y equals pi x over 4. Okay, and if you're following along from that last example, in that function that I showed you with the shifts and scaling, our b in this case would be pi over 4. Okay. But let's graph our cosine of x function real quick, just our normal parent function. Remember, this crosses over at pi over 2, or negative pi over 2, and 3 pi over 2. Okay, so that was a full cycle, and now let's carry this out. And this was negative pi over 2. This was 3 pi over 2. Okay, so I am compressing it by pi times, which means I can take this 3 pi over 2, multiply it by 1 over pi, that's our compression, that's going to cancel, just leaves me 3 over 2, and then we have a horizontal stretch of 4, so we will multiply this. We will multiply this 3 over 2 times 4. All right, which this cancels. This just equals 3 times 2, which is 6. And we can do the same thing for the other side there. We have negative pi over 2. That is compressed by pi. That means that pi cancels. And I'll just write it out. That cancels. This equals negative 1/2. And then we have a horizontal stretch of 4. Take that 1/2, multiply by 4. That's negative. And we're going to come out with negative 2. Okay, so our new x-intercepts are 6 and negative 2. So I'll draw this in yellow. We're going to have negative 2 and 6. All right, and it will still have the same y-intercept at 1. That doesn't change. Okay, and that's your new function of y equals cosine pi x over 4. So what would the period be for this? Remember, the period is distance of a full cycle. Let me just fill this in. Okay, so we got from negative 2 to 6. That means our period is 8. Okay, so the way I look at these trig functions, when I have any types of these shifts or scaling, I just look at the endpoints and I do exactly what the scaling is, and that helps me figure out where certain points are going to be for my new graph. Okay, and I say endpoints. I refer to endpoints when I'm talking about cyclic functions, and I'm just talking about the endpoints of this cycle. Okay, let's move on to the next example. All right, I made up a fun example for everybody for this one. So we have y equals sine pi x over 4 plus 2. Okay, and remember, this is a vertical shift, this is a horizontal compression right here, and this is a horizontal stretch, and your sine function is just your parent function. Okay, so we are going to have a y-intercept at 2, because then our y-intercept for sine of x is just 0, so we can just add 2 to 0. And then we have a horizontal compression of pi. And let me just, before I get too ahead of myself here, let me just graph sine of x here. I think we all somewhat know what that looks like. And this has x-intercept at pi, or negative pi, and a positive x-intercept at pi. So if we are compressing this, we can just divide those endpoints by pi. So we can say sine, and I'm just going to put endpoints. And I just want to make sure this is clear when I'm saying this. And pi. And then I'll just put this in yellow. And I'm just going to say, f of x, right? This is f of x. Okay, so this is being compressed, so we're going to divide that by pi, divide this by pi, okay? And then we have a horizontal stretch of 4, so we can multiply our endpoints by 4. So negative pi over pi is 1. Multiply that by 4. We're going to have negative 4. Pi over pi is 1. Multiply that by 4. We have 4. Okay? And we know our amplitude for sine of x is just 1. Right? And remember, this is, I can put this in blue. That's just your amplitude. Nothing changed with amplitude as we didn't change any vertical scaling here. So we can come up here. Our endpoints are at negative 4 and 4. So all you do is it follows the same exact pattern as the other graph. I suppose we can continue that. All right, and let's highlight this whole period, or this whole cycle, so we can identify what the period is. Okay, what's that distance? Remember, our endpoints are negative 4 and 4. Difference between that. Is 8. Okay, so our period here is 8. And for this next example, I will do some vertical scaling so the amplitude is changed, so you can kind of see when, when we're going to actually be changing the amplitude and when it's not just 1. All right, let's move on to that example. All right, and for this example here, we are going to have y equals 2 cosine pi x over 5 and plus 3. So let me first start off by graphing just cosine of x. That has x-intercept at pi over 2, or negative pi over 2, and 3 pi over 2. Remember, this is cosine of x. Okay, and you can either write like x-intercepts. I like to, for some reason, I write endpoints. And I write endpoints because I think of endpoints as the end of this cycle. So I'm just trying to graph a cycle, and then I'm going to move on from that to try to graph the rest of the graph. That's just the way I look at these problems. I think it makes it a lot easier. But let's just go through this. So we have this negative pi over 2 here. And we have 3 pi over 2 over here at the end of our cycle. And remember, this is pi over 2 as well, so we can use that as well if we wanted to. Okay, I'm going to put this in yellow. Okay, so our endpoints of our cycle for this would be, there's a horizontal compression, so that means this has to be divided by pi. This has to be divided by pi. Okay, so now we have, this is going to equal negative 1/2. This is going to equal 3 over 2. I was going to write just 1.5, but we'll keep it in fractions. 3 halves, and then we have a horizontal stretch of 5. So we'll take negative 1/2, multiply that by 5. That will be negative 2.5. And we have 3/2 over here. Multiply that by 5. That is 7.5. And just for fun, what's that? Pi over 2 in the middle right here. That'll be, once we divide by pi, that'll be 1/2, and then multiply by 5, that'll be 2.5, which makes sense, right? We know this is going to be, that point's going to be somewhere in the middle between here. And the reason I don't usually write that specific point out, because we can assume that's going to be right in the middle of this, negative 2.5 and 7.5. What's in the middle of that is 2.5. Okay, and then we have a vertical shift of 3. Okay, so we know we'll have a point there. We know we'll have a point at negative 2.5, 3, right there. Another point right there, and another point right there. And we have a vertical scaling of 2. We have a vertical stretch of 2, so that means that when we're graphing this is going to have to come up to here. This will come down. Okay. And there's your graph. So hopefully that makes sense. I hope this wasn't too confusing, me calling these endpoints throughout the video. I just call them endpoints because I think of it as a cycle. You know, when I'm looking at these problems, I'm always looking for the period and the amplitude. You know, you can call them x-intercepts, you can call them whatever you want. All right, and let's highlight our cycle in here. That's half a cycle and a full cycle here. So our period is going to be from negative 2.5 to 7.5. So that's just 10. And our amplitude is going to be from 3 to 5, which is just 2. Okay, so our period is 10, and our amplitude is 2. Okay, let's move on to the next example. All right, and for this final example here, we're going to have y equals negative sine x over 2. Okay, when I look at this, I'm immediately seeing that's this 2, and I'm immediately seeing that negative. This 2 means there'll be a stretch of 2, so stretch by 2 times, and this negative means there'll be a flip over the y-axis, okay, or y equals d. But in this case, our y is 0. Okay, so let's graph this sine function. It's going to be coming down here. It's going to cross right there. It's going to come over there. Okay, and this is negative pi. This is pi. So I'm just going to put endpoints like we've been doing in the past for past few examples. We have negative pi and pi, and then we are going to have a horizontal stretch. So we can take our previous endpoints and just multiply them by 2. So our new endpoints are going to be negative 2 pi and 2 pi. Okay, and with that negative out front, this is basically all just going to, imagine this is just flipped. Okay, this is going to go down there, that goes up there. Don't pay too much attention to that. It'll make more sense when I graph it, if you don't already understand. Okay, so our new intercepts here are going to be negative 2 pi, so that should be like negative 6.28 and positive 6.28. Okay, and we are still going to have that intercept there. Okay, I think that is pretty good. I'm happy with that. All right, let's just highlight our cycle here. Okay, so half a cycle, rest of the cycle. All right, so what's our period? Period is the distance of that full cycle. So we can just look at our endpoints, look at the difference. 2 pi minus negative 2 pi is 4 pi. So our period here would be 4 pi, and our amplitude did not change because we have no vertical scaling. So that should stay the same. So we'll just write period Okay. So I hope this video cleared up any questions you may have still had about this topic, and everything was clear and concise for everybody. If you enjoyed this video, please like it, and if you enjoy my content, please consider subscribing. You can always unsubscribe if you'd like to. You get tired of my notifications or whatever, but for the time being, why not? Why not subscribe? But until next time, everybody have a great day, and I'll catch you later. All right, bye.